complete graph. Complete graph. What is complete graph? It is simple regular graph. So complete graph is simple regular graph. A simple regular graph in which there is exactly one edge between every pair of distinct vertices. Okay, so what is complete graph? A simple regular graph. It is simple and regular. So no parallel edge, no self loop. Okay, no parallel edge, no self loop, and degree of each vertex same. So a simple regular graph in which there is exactly one edge. Between every pair of distinct vertices. Okay, so every complete graph, it is simple, regular. So no parallel edge, no self loop, and degree of each vertex same. And there is exactly one edge between every pair of distinct vertices. Okay, see one example. Suppose this is one vertex, this is another vertex. These are 5 vertices. Okay, so it is simple regular graph, no parallel edge, no self loop, and every pair of distinct vertices. Suppose these two. Take any two vertices, you will find exactly one edge. Take these two vertices, you will find exactly one edge. Between these two vertices, exactly one edge. These two vertices, exactly one edge. These two, exactly one edge. These two, exactly one. These two, exactly one. Exactly one. Okay. So this is one graph having 5 vertices, and there is no parallel edge, no self loop, and there is exactly one edge between every pair of vertices. Take these two vertices, you will find exactly one edge. Take these two vertices, you will find exactly one edge between every pair of distinct vertices. Take any two vertices of this graph, you will find exactly one edge between these two vertices. Okay, so this is one example of complete graph having 5 vertices. So this graph is K5. What is K5? K5 is complete graph having 5 vertices. Okay, complete graph having 5 vertices. This is one example of complete graph. So take any two vertices of this graph, you will find exactly one. So this is one example, K5 complete graph having 5 vertices. Now example of K4 complete graph having 4 vertices. Take any 4 vertices, and between every pair of distinct vertices you will find exactly one edge. So this is K4. Okay, and K3, take any 3 vertices. So this is example of K3, this is K4, this is K5. Now in K5, degree of each vertex, degree of this vertex is number of edges incident to this vertex 1, 2, 3, 4. So degree of this vertex 4, degree of this vertex 1, 2, 3, 4. Degree of each vertex same. It is regular, simple regular graph. Degree of each vertex same 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So in K5, complete graph having 5 vertices, degree of each vertex is 4. Okay, in K5, degree of each vertex is 4. In K4, degree of each vertex is 3. In K3, degree of each vertex is 2. So take one complete graph having n vertices. Take one complete graph having n vertices. Degree of each vertex is degree of each vertex is n minus 1. So for complete graph having n vertices, degree of each vertex is n minus 1. Okay. Now question is find number number of edges of complete graph kn. Kn is one complete graph having n vertices. Find number of edges of complete graph kn. Kn is one complete graph having n vertices. Find number of edges of complete graph kn. So in kn complete graph having n vertices, degree of each vertex is n minus 1. Degree of each vertex is n minus 1, and the number of vertices is n. Degree of each vertex is n minus 1 and number of vertices is n. So sum of degrees of all the vertices, sum of degrees of all vertices, sum of degrees of all the vertices, it is n into sum of degrees of all the vertices of this complete graph kn. Kn is complete graph having n vertices. Sum of degrees of all the vertices of this graph kn is, each vertex has degree n minus 1 and number of vertices is n, so it is n into n minus 1. So sum of degrees of all the vertices of complete graph kn is n into n minus 1. Now by handshaking theorem, sum of degrees of all the vertices is 2 into number of edges. 2 into number of edges. So number of edges equals to n into n minus 1 divided by 2. N into n minus 1 divided by 2. See, question is find number of edges of complete graph kn. In kn, degree of each vertex is n minus 1. So sum of degrees of all the vertices, degrees of each vertex is n minus 1, number of vertices is n, so sum of degrees of all the vertices is n into n minus 1. By handshaking theorem, it is 2 into number of edges, each number of edges, so equals to n into n minus 1 divided by 2. So in kn, number of edges is n into n minus 1 divided by 2. This is the maximum number of edges in any simple graph. In complete graph, number of edges is n into n minus 1 by 2, and this number is the maximum number of edges, possible number of edges in any simple regular graph, in any simple graph. Okay.